So next up, I want to talk about power, please, Kevin.
Yeah.
So the big question I think that our viewers will be wanting to understand is why on earth does power matter in HiFi? Most people live in a home, you'd like to think, and we've all got the same copper wiring in the mains. There's kilometres of cable running to that. So what we talk about the last meter a lot. So why does that even matter to begin with before we get into the product?
Yeah, I think generally speaking, Atlas, when we look at power cables, there are various priorities. Our first priority is safety, right? So a power cable, it's not an analog interconnect. It's get plugged into the wall and it's delivering current and voltage to your devices. So therefore the first thing is safety, right? Which is, so we developed the fundamental raw cable. Number one priority all the time is safety and how we actually develop that. Now, when we then are looking to develop products from power cables, then my personal view and my experience is that the vast majority of performance that you can hear from changing in and out power cables is primarily comes down to the screening performance of these cables. Okay. And again, that goes back to your point, is why does the last meter matter? Because usually the last meter is the point where the power cable comes into your environment, it comes into your room. And the one thing's for certain is if you plug any cable into a power socket and there's any noise or a high frequency noise within the wiring of your house, is going to radiate out your power cable. And you go, well, why does that matter? So what you're trying to do with a good quality, high quality screened power cable is reduce the RF load on your HiFi system. Right? And what I mean by that is, if you have unscreened power cables coming out, and often you get them free in the box, they come in the box, they're absolutely safe, so spot on. Yeah. You plug them in, they deliver performance. However, that cable itself is radiating broadband RF energy. And if you then don't take care about how to control that in the rest of your system, and what I mean by that is in Atlas world, we would say by using good quality screened cables, by using the grun system in your HiFi system. So if you don't take care of that, then the effect of the power cable and the rest of the system is quite profound, right? So what we do, because again, we're selling power cables as a component into systems that have no other Atlas cables. Yes. So people are choosing it. So again, on its own, it has to have its own, merit. So what we fundamentally have is that in a raw cable, we adopt and we apply different screening technologies to effectively produce higher quality screening performance for a power cable. So as you go through the range from, like, for example, the EOS 4EM up to the EOS 4EM Superior, then what's changed primarily is not the cross-sectional area of the cable, because they're both 4 square millimetre, but the levels and the integrity of the screening in the cable. So the Superior will deliver better screening performance and therefore will deliver better fidelity overall. And what we've been doing recently is we've been extending that range. So we're now going to launch, and you've got one in your hand there. Yep. It's an EOS Superior 2.5 EM. So this is a cable, it's a 2.5 square millimetre conductor. It has 3 layers of screening. It has a graphite loaded screen. People say, well, why different between graphite loaded screens and metal screens? Well, the first level is a graphite loaded screen, as it provides screening, but it also maintains the integrity of the product as it's being flexed. One of the requirements of cord sets, generally speaking, is that they've got to be flexed. You've got to be able to flex them 10,000 times without any breakage, because it's a safety device.
Okay.
So the internal first layer of screening within the 2.5 EM is this graphite loaded screen. So it gives us screening, gives us protection. We then follow that up with 2 other levels of screening in the product, which improve and increase the percentage covering. So, for example, in the market, you might have something like, when you've got a screened cable, sometimes it's defined as like 80% screened, 85%. This relates to the integrity of the screen, and a metal screen. What that means to say is, how tight is the screen, the weaving of the screen, how tight is it coupled together?
Okay.
Right? So the tighter you can make that weaving in the screen, the more efficient the cable is at controlling RF coming in and RF getting out of the system.
But in our case, we're talking about 3 levels of screening within this particular product. So the 2.5 EM Superior fits into, we've talked about the Duo products being part of the Aspire range and taking that up into a higher level. We have Upgrade below that, and we have High End above that, and the 2.5 EM Superior fits into the high end.
Yes.
So that is because we are, so again, just for everyone watching, the difference between the 2.5 EM Superior and the 2.5 EM would be that they've got its additional screening.
Absolutely, so a lot of additional screening. And we also take care, I mean, again, when we're looking at the product, we do other things. So one of the other things you want to do in a power cable is you want to have a low contact resistance. So the quality of the plugs, the mains plug and the IC plug, very, very important.
So
right?
For any layman's, might include myself in that, what do you mean by low contact resistance? Well,
the contact resistance is effectively is that because you're passing power through there, it's a basic Ohm's law. If you plug a plug into a socket and you have you have a dirty socket there, and you have a plug that the surface isn't smooth, hasn't been polished up, then the contact resistance is higher. At the contact, if you pass current through it, it's a place where you lose power. Now, it might be small amounts of power, but the cumulative effect of all the junctions, the plug to the wall socket, the IEC to the socket on the back of the product, these all are places where you lose. And from our experiences, if you can reduce the places where you lose, or reduce the amount that you can lose at any contact point, there's the potential for a better fidelity exists upstream from that. So what we do is we make sure that the material, the plug pins, for example, the 2.5 Superior, it's OFC copper pins, they are polished, and again, one of the other things that the product is gold plated. Now, just to cover that bit, plating, the plating is there purely to negate the effect of if it was a OFC, oxygen-free copper pin on its own. Well, copper oxidizes, and copper oxide is an insulator. So you plate the pin in the plug to remove that. The plating itself, we would suggest would be less as important than how smooth the finish is on the plug itself. So smooth finish on the plug, the plating on the plug just to stop the oxidization, low contact resistance for that plug, attaching it to the cable in the right way and making the contacts airtight. We take every contact within the plug itself and we seal them and make sure that there's no air getting in as much as possible. Because again, it's a place where you stop oxidization, you'll stop the product performance reducing over time. So these are important things for us, as well as the electrical issues that you do in cable design. It's mechanical as well.
Just quickly reverting back to the screening side of things, I'm quite interested in that, because you've got the safety requirement of a power plug, power cable, versus something that we offer screening within our interconnects, speaker cables, etc. Is that a different consideration for you over and above something we put into an interconnect versus a power cable? It's a lot more go into that in terms of the thought process.
Yeah, well, I think fundamentally the core product has got to be compliant with the regulations that needs to happen, and that's why I say we start with the basis of safety first, compliance. That's why we use carbon loaded screen as the basic. When you then subsequently put on different layers on that, you're taking care of each of the layers when you apply them, how you apply them, and how they go together, because you're fundamentally taking care of the bit at the beginning, which is the basic cord set. How compliant is it going to be? And it has to be 100% compliant to all the specifications, so you've taken care of that. But you can, as we all know, specifications everywhere define the minimum standard, not the maximum, right? Okay. So we are always looking to see how can we improve on a standard, you know? And I think that's what we do, and that's what we do best, because we take what people would accept as being acceptable, and we take it to the next stage.
In terms of on an upgrade path for any customer that was looking to start out, would they consider going in any particular order first and foremost? If it was like power first, or to look at speaker cables, is that very much personal thing, or is it?
I know my personal thing is that I would hierarchy for me says it's interconnects, speaker cables, power, because you find with power, I believe, because we talked about for us it's to do with screening. If you just get one power cable and the other five, right? So what it says, power cables for me tends to be something that you would do if you could budget, right? You would do as a winner, do all your power cables, screen them all,
okay.
Right? Now for us that's okay, because you might not decide to go and do 2.5 or 4.5 EMs. You could have a 1.5 EM and a 2.5 EM and then a superior on that, but they would all be screened, and by it all being screened, you would have, the reason you've screened them is to reduce this RF loading. So whereas you can add a single interconnect that can make a huge difference, and power cables can make a difference, but I suggest that the best use for us of your budget would be to look at power as a complete entity.